Hey friends, if you are new to the world of the data, you might start hearing many terms and buzzwords that might be confusing. I have been explaining those terms using animated sketches on my iPad with Procreate. All of them are hand-drawn, so nothing is AI generated. So now I have collected everything in one video, so grab some popcorn, sit back and enjoy the data movie. Let's go. The role of the data analyst. So what is a data analyst? Well, it is very simple. You answer the business questions using data. Think about yourself as a bridge between the raw data and the real business decisions. So now I can say that I have joined like around 7 data teams and projects. And now I would like you to understand exactly what data analysts do in real companies. So now it is story time. Let's go. Okay, so now in companies, in business, we have managers, stakeholders, project leads, and their whole job is to make smart decisions by asking critical questions. So for example, which region is underperforming? Why are profits down? And should we invest here? So there are many challenges in the business and they need quick and smart decisions. So now without using data, they are just guessing. They rely on opinions, gut feelings, and many outdated informations left and right. And there is famous quote from William Deming I really like and use a lot. Without data, you are just another person with an opinion. So that means if your decision process is based on opinions, this has high chance to lead to confusion, wasted resources, and making bad decisions for the business.
I think that pretty much sums it up.
So now instead of guessing, they have to decide based on data. So now in companies, the data are scattered everywhere. Your data is stored in many different databases. There are a lot of spreadsheets and maybe as well APIs that provides data. So they are everywhere and the managers of course don't have the time or the skills in order to dive into all those places. So that's why they go and hire an expert, a specialist. They hire the data analyst. So think about it like you are a detective and you start gathering data from different sources. So you go and query the different databases and as well pull the data from the spreadsheets and the different APIs. So you have to go and get the data wherever they live. So now of course all those data are messy and you have to go and clean and structure those data. So maybe you're gonna go and put the data everything in one spreadsheet like in Excel and you start doing a lot of stuff on the data, cleaning up the data, organizing it, doing a lot of calculations, transformations to get the data ready to answer the business question. Now after you find something meaningful from the data, you start turning the data into insights, into a visual report, because it is way easier to communicate the result to the stakeholders and managers using visuals. So that means once you are ready, you go to the managers and you start presenting the result as a story using the report and visuals that you have prepared. Now the managers got facts and this time they have answers to their questions using data. So now they are more confident and they make better and smarter decisions for the business. So now you can see clearly what the data analyst does. He or she is the bridge between the raw data on the left side and the business on the right side. And all what he is doing is answering the critical business questions using the raw data. And as well, it is very clear which skills this analyst needs. So as we understood first, you will be querying the databases in order to pull the data. And in order to talk to the data and the databases, you use SQL, or sometimes we call it SQL. And we have understood as well, once you collect all the data, you will be using spreadsheet like Excel in order to clean, sort, filter, and do calculations on the data. So they have to master Excel. And after analyzing the data using the spreadsheet, you need a data visualization skills using tools like maybe Power BI or Tableau to create charts and clear visuals to be reported to the managers. And of course, one very important skill and crucial, you must clearly understand the business questions from the managers and communicate the results and the findings very effectively. So you have to master this skill. You have to tell a story behind the data. So you need really very good communication skills. So that means if you master those skills, you will be an amazing data analyst that's gonna help the company and the managers making the smart decisions. And now, my friends, we have an issue. This might work for a small company, but it will not work for a modern big companies. And here's why. Now, big companies generate big data, and it's gonna be really hard for the data analyst to manually extract the data for analysis, because you're gonna need a lot of data and your request gonna take like hours and even days to get the data, and it might crash and it's gonna be sometimes impossible to get the data. So it's gonna be for you as a data analyst really hard to answer any questions, and your process is gonna take weeks until you give any answers. And of course, managers cannot wait for weeks in order to get like an answer. So my friend, this approach will not work. This is simply does not scale. So now we have to go and scale things and hire new people. Now a data architect, it's like an architect of a building. You have to design the blueprint of a scalable data system, and you have to go and organize the data into multiple layers. Like for example, the Mendelian architecture, you have a bronze layer for the raw data, and a silver layer for a clean data, and a gold and very important layer for clean, structured, and optimized data. So all what the data architect is doing is designing this scalable data system. So now as you can see, the data architect is designing this scalable data system, but as usual, they are not the one that is building it. For that, we need another experts, and we call them the data engineers. So now as a data engineer, you're gonna go and build something called data pipelines. Well, it's all about to connect to multiple source systems and start automatically moving the data from the sources to the new data system. And as well, very important, the data must move quickly. So the pipeline is gonna bring the data to the first layer, to the bronze layer. As a raw data, nothing fancy gonna happen here. Then the data engineer gonna move the data to the silver layer, and there the data get cleaned, structured, and prepared for the final layer. Now in the final layer, the data engineer gonna go and build a data model, which is highly organized and optimized model that is perfectly made for quick analysis. And we have with that a process that runs automatically from the source systems until the final layer, and this runs every day very fast, and in some scenarios as a stream, like a real live data. So remember now our data analyst friend. So now thanks to the data architect and the data engineer, analyst's life now is way easier. No more nightmare of pulling the data manually from the source system. No need anymore for the spreadsheets and the Excel lists. Now everything is prepared for the data analyst to be fast.
Hell yeah! Hey, come on, baby! Come on! Yes! Come on!
So now again, as a data analyst, once you get a question from the business, you can go quickly and straight away to the gold layer where everything is prepared. And now using SQL, you will be querying the data model in the gold layer in order to explore and try to find answers for the question. So once you find it, you will go and build again like a visual report and tell a story for the managers. And with this setup, you only focus on what matters, on finding answers for the business. And this can speed the whole process for you, and you will be ready to answer quickly the questions. Now, I'm really sorry we are not done yet. There is still an issue in this story. Now, all what you are doing here as a data analyst is that you are answering ad hoc questions, and your answers are always like one-time reports. But what can happen for sure is that one of your reports gonna deliver really an incredible value, and it is not just useful for once and only for the managers. Many people across the company gonna be interested in these reports. So you're gonna have a new user groups that's gonna ask you one question. I want your report every day.
No! God, please, no! No!
And the nightmare gonna come back where you have every day to run the same query and generate the same reports, and you're gonna daily send these reports to the users. And this gonna be total waste of your time and gonna build huge stress on you. And that's why companies gonna bring another person to the data team, and this time we're gonna have the business intelligence developer or BI developer. So once the BI developer joins, you as a data analyst gonna say, hey, go and automate this report and make it visible for many users. So first, the BI developer gonna build an environment like a server where the dashboards and reports gonna live. This must be secure and has an access management. Sometimes you cannot give all the data for everyone in the company. And as well, this server must be accessible 24/7. So the reports and dashboard must be always available. So once the reporting server is there, the BI developer gonna take everything, the report, the logic, and build from it something called interactive dashboards. And what is very important, this dashboard gonna be automatically connected to the gold layer, to the data model. So that every day, and this is important, the dashboard and the reports gonna get fresh data from the data system, from the gold layer. And once everything is live, the user is gonna go and start requesting access to the reports and start accessing the dashboards and the data. Everything is highly automated and scalable. So the data gonna flow from the sources into the different layers of our data system and as well automatically flowing to the reporting server and refreshing the data there. So this is the big differences between the data analyst and the BI developer. The data analyst is the one that is bringing the first report and insights, and once a visual or a report gets very important, the BI developer is the one that is responsible of making this report accessible, scalable, and everyday available for many users. Now, so far we have helped the business and the managers with questions that are about the past and the present. What happened? How much did we sell? Why did sale drop? But at some point, the manager's gonna ask bigger questions. Questions about the future. What will happen next month? Can we predict which customers might leave us? What can happen if we change our pricing strategy? So they are advanced questions about the future, and to be honest, the data analysts don't have the tools in order to answer them. And for that, we need another expert called the data scientist.
This is Sheldor the Conqueror. We are about to enter Atzel's fortress.
The data scientist is the one that's gonna use the data in order to build and train models. They're gonna do a lot of experiments, so at the end the scientist gonna use this model in order to give answers for the future. So with that, the managers are not just informed, they are as well prepared for the future. They are proactively making decisions, they stay ahead of the competition, and as well they tackle challenges before they even appear. Now this type of work is very important thing not only for the managers and projects leads, this is important for everyone else. Now this model, this work from the data scientist must be visible for other users. And this is the same thing that happens before, right, with the BI developer. But now we need another type. We have the machine learning developer, ML developer. So now what they're gonna do, they're gonna as well prepare a server and environments to run and deploy the model from the data scientist. So they're gonna go and put it in productive environments, and everything gonna be now automatically secure, scalable, and available 24/7. And the result of this model could be presented in like an application to show the result of the predictions for everyone, or as well sometimes they show it in dashboards and reports. So their job is to make the result of this model available in many services in the company and accessible by other users and built by the ML engineer. And with that, everyone from the managers to teams across the company benefits from advanced predictions every day and anytime. So now by looking to this, everything is highly automated. The data can flow from the sources to the data system and then flows to the reports and dashboards, and as well automatically flow to our model that is trained from the data analyst and built from the ML engineer. So this is what a modern big company built. They build scalable data system. Now if you look to this, you can see there is a pattern. You can see the data architect is working closely to the data engineer to build the data system. The data analyst works as well closely to the BI developer in order to build this reporting system, and the data scientist together with the ML engineer, they work on building an advanced analytical system. And there is actually another pattern. You can see in those roles there is always somebody is like doing a design, like the data architect is like designing the data system, and the data analyst is like building the first version of the reports. Same thing for the data scientist, he is the one that is experimenting and training the first version of the model. So those ones are always like trying to discover, trying to put the blueprint. And now in the other side, we have the other category. You have the persons that are building it, bringing it to a productive, scalable environment and making things live. Like the data engineer is the one that builds the data pipelines and this data system. The BI developer is bringing the reports and dashboards into scalable and productive reporting system. And the machine learning engineer is the one that is bringing the model and deploy it into a productive system and offering the results in different services. So they are the engineers, they are the developers. So this is what a real modern data team looks like. Alright, now the story with the data always starts with a problem in the business. So we have a business question like, for example, how many customers do we have in the last quarter? Now, of course, it is a smart thing to ask the data instead of having gut feelings about the problem. That's why we try to get the answer from the data, and for that we hire the data analyst. So now the data analyst is going to open their tools and start pulling the data from different sources, maybe from the sales system, customers database, and product logs. And of course, they are in between many steps, but at the end, the data analyst is building a report, a dashboard, using BI tools like Power BI or Tableau. And of course, using visuals, it is always easier to deliver the message, the story behind the data for the business users. And now, once everything is ready, the data analyst is gonna go and present the result for the business users. But now this is gonna scare everyone. The trends is going down, we are losing customers in the last 3 months, and everyone starts to panic. And now what's gonna happen? Of course, one of the managers gonna ask a very important question. Can we predict how many customers are going to leave in the future? So which customers are likely to leave, so that we can take an action maybe in order to prevent that. And now if the managers go and ask the data analyst about the predictions, highly likely you will get an answer like this: well, I have only Power BI, I can only show you the data for the current situation or the history, but I can't make something very intelligent in order to predict things in the future. And my friends, exactly for this scenario, as we get more complicated and advanced questions, we need a data expert, a data specialist in order to solve this problem. And here comes the data scientist. So that means if the business question is all about the current situation or maybe the past and the history, then we need a data analyst in order to do something called descriptive analysis. But now if the question is looking to the future, then we need a data scientist in order to do predictive analysis. And of course, this type of analysis, it is way more complex than the descriptive analysis. And for that, we need like an intelligence system. Using tools like Power BI, Tableau, SQL will not really help. So now let's see how our friend, the data scientist, gonna solve this problem. Now, of course, for each problem, we need always data. That's why the first step is to collect the data. But now this time the data scientist needs way more data than the data analyst. So anything the company is generating about the customers gonna be important in this phase. So the data gonna get extracted from databases, logs, spreadsheets. So everything that is related to this issue gonna be collected in one place. So now of course all those sources speaks different languages and they structure and store their data differently. So that means the data stinks, the data is chaotic, and it's time to get hands dirty. So that means in this phase we are doing data preparations, or let's say like pre-processing. Like for example, we can go and merge those files together and the sources using joins, and we have to check the content of the data. If there are a lot of nulls, we can go and replace them with something more meaningful. And another thing that we can do is that we can correct the data types, maybe remove the duplicates, maybe there are like columns that are totally useless. Now this step is really time consuming, like you spend 70 time of your total projects only doing those stuff, only cleaning and preparing the data for the next steps. And of course, if you are lucky and have a data engineer like me in your projects, then we're gonna go and prepare all those stuff for the data scientist, so that the data scientist only focus on the next steps. But you don't have this luxury in each company, that's why mostly you will end up doing those stuff. Alright, so with that we have now a perfect data set that is clean, structured, and ready for the next steps. And now you might get excited and say, yes, now we're gonna go and do some magic, some AI and machine learning, right? Well, I have to stop you there. Before we touch anything about machine learning, we have to do something very important. We have to explore and understand the data. So we have to do something called exploratory data analysis. So what we're gonna do, we're gonna go and open our notebooks and start asking questions, like for example, how the data is distributed, how we can cluster the customers, is there like any outliers, what are the relationship between like different measures. So with that, you are exploring and understand the content of the data, and this is something that we will not go and share with the stakeholders. This step we do it for us, the data scientist, in order to understand the data. It's like doctors, they read the charts before doing any diagnosis, right? So it's like a thinking phase. You look at the data, ask questions, and make notes. So now once we have a good feeling about the data and we feel confident, we can move to the next step. And the next one is very powerful, but yet very underrated. Sadly, a lot of data scientists skip this. Now the scenario is like this. The dataset that we have is, yes, clean, prepared, but the data itself, it is very raw. It is not yet like an information. Like for example, you could have a column called the sign up date of the customer. Now this is very raw. Instead, we can make like an extra column. We can derive a new column and we calculate the days since the sign up. So that means we are creating new columns. We are deriving informations from the raw data, and we can create other measures, like for example, the total spent by customers, the average session duration. So we are deriving smart columns that don't exist on the original dataset. And of course, they are not easy to create. Procreate, you need some domain and business knowledge. That's why we have done the EDA phase, right? And this is very important. I really don't get it why some skip this phase. The quality of the features that you add to the dataset gonna decide really the outcomes of your work. So this is what we mean with the feature engineering. We are deriving important informations from our raw datasets. And now, my friends, with that, we have everything. We are ready and it is magic time. So it is time to do some machine learning. So now the first step is that we're gonna go and split our datasets into two sets. The first one is the training set, where our model gonna learn from. And the second one is a smaller one, the test set. We're gonna use it in order to test the performance, the output of our model, because if you train and test at the same datasets, basically you are cheating. So we don't do that. We split the datasets. And now the next step is the most important one. We have to choose an algorithm. An algorithm, it's like a set of mathematical steps that describes how to learn from data. So basically this is completely mathematics. And what we have to do is that to understand those algorithms, because we have many different algorithms and we have to pick the right one for the right problem. So now once you pick this algorithm, the next step is that to go and apply the training datasets on the algorithm. So now we are combining mathematics with data. So the algorithm gonna go through all your data and start learning from the datasets. And this is what we call, my friend, training a model. Now that means the model gonna start learning the patterns. It's gonna go and find connections and relationships between the data, and it's gonna start adjusting itself as well to minimize the errors, so that at the end we get something very powerful called a trained model that we could use in order to do predictions for new data. Now the output of this trained model gonna be predictions. So it could be like, yes, the customer is likely to stay, or no, this customer might leave soon. So we are labeling each customer, or we could have like percentage on how likely the customer gonna leave. Now, of course, we have to share now this knowledge to the business users. What we could do, we could import everything, the data and the predictions in Power BI or Tableau, and build again like a visual in order to show the final results. So as you can see, it's always a nice thing to communicate with the business users using BI tools, because they are very friendly compared to maybe like visual inside your notebook. So now we go and present the results for the business users, and now they have more understanding what could happen in the future. Now next what's gonna happen, they're gonna plan actions. So maybe they're gonna go and launch retention campaign, or maybe send new offers to the risky customers, or maybe the sales team gonna go and reach them directly. And this is the most beautiful moment as a data scientist. You see, you are adding value to the company. You are not just building like a fancy model because you could. You are really helping the business to see what is coming and to do something about it. Now this sounds like an happy end, right? You have delivered your work, you have improved the business, and that's it. But sadly, the bad news is that we are not done yet. So far, everything that we have done is manually, and as well, like we can call it prototyping. But now, of course, this is not one-time activity. We have to continue doing those stuff, and you cannot keep doing everything like manually on your notebook. And of course, the sources keep generating new data every day, and maybe they are useful informations that you have to train the model again. So now we are at a point where we have to automate everything and make deployments. Deployments means we take everything that we have done manually so far and put it in real automated system. This system, of course, should not run locally at your notebook. We have to run it on servers, for example, in the cloud. And of course, what we can do, we can use APIs in order to connect internal applications and system in the company to the model in order to show those scores at the front end. So the whole thing is all about to bring everything that you have done manually at your notebook and to deploy it to professional platform that is fully automated, scalable, highly available and secure, and connectable to different applications at your business. And if you are lucky enough and you have ML engineers or ML ops, they have to do those stuff. So as a data scientist, actually, this is not the thing that we do. But if you don't have them, then you have to do it on your own. So now, my friends, everything that you have just shown, like collecting the data, preparing the data, training the model, this is what we call classical machine learning process. Because we are now in 2025 and we have entered the world of pre-trained models, especially the LLMs, large language models, like GPT, Claude, Mistral, and others. They are models that already trained on massive amount of data in the internet, on public data like text, website, documents, and they already understand language, context, and reasoning. And this is really crazy because before we have like models and we have always to train the models, but now everything is prepared for you. We have models and as well they are pre-trained with massive amount of data. But now you might say, yeah, okay, those pre-trained models are really good, but they are very like generic. They trained on the public data. In the companies we have like special data. Well, it's fine because most of those models, they allow something called fine-tuning. So that means you can go and pick one of those pre-trained models and train it, fine-tune it with the company's data, and with that you make it smart with your domain, with your business. And now you might ask, okay, why we need all those LLMs? Well, think about it like this. If each time the stakeholder or manager need like a new report or new informations from the model, and you go and jump and get the data from the model, put it in Power BI and then present it for the stakeholders, this is really slow. So instead what we can do, we let the user have a chat with the model, and the users could start conversations like, for example, why are customers leaving region B? Summarize all the feedback from the cancelled users. So they're gonna have like a chat with the model, and this is way better than waiting each time for your Power BI reports. And for that we could use the help of those pre-trained models, the LLMs. And now of course comes the scary part where you ask, if we have all those pre-trained models, why do we have even data scientists? I understood from you we need data scientists in order to train models, but if we have pre-trained models, why do we need them? Well, first of all, my friends, everything that I have described is the industrial data scientist. So someone is hired in the company to do those stuff. But the one that pre-trained those data models, they are as well data scientists. But they are not hired from the industry. They are actually researchers. And of course, they work in massive engineering teams in big tech companies like OpenAI, Google, Meta, and they do the amazing work of bringing those pre-trained models in the market. And from the other side, of course, we still need the industrial data science for one very important reason. Well, my friends, all those LLMs and pre-trained models, they are trained on public data. And most of the companies, they don't bring the data on public. They all internal, confidential, and even secret. So there will be a lot of business problems that depends on the company's data. And as long as the companies protect their data, we're gonna end up in the situation where we need to hire data scientists in the industry so that they either fine-tune the pre-trained models, or in many scenarios, they have to train from the scratch the models using the company's data. And that's why the data scientist in the industry is very relevant. And to be honest, we have now a lot of work to do because we suddenly exposed to all those pre-trained models and we have to fine-tune a lot of new models. So I am very positive and excited about it, that this can accelerate our work. This can open the door for many use cases that I never thought before. And believe me, we have a lot of work to do. So back to our story. Now we come to the last thing that we know so far. We have something called AI agents. So now we are far beyond having a quick conversation between the business user and your model. Now the user is gonna ask for many stuff. Like, for example, how many customers did left last year? So what we can do, we can have like one AI agent that is using pre-trained model to convert this text into an SQL query that goes directly to the database and grab the data. And of course, show it at the end as visualizations. And another thing the customer might ask, for example, where I find the customer's data in which system, in which application. So for this scenario, we can use another AI agent that could use as well pre-trained model that's specialized on scanning documents. So this time we don't need the company's data, we need the documentations of the company. And now if the customers ask something about the future, how many customers gonna leave next year, then you can use an AI agent that connects to our model that we trained from the scratch, that we are very proud of. So if you look to this, we're gonna have a lot of AI agents that are connecting to different models, connecting to different data and sources. So of course we have to orchestrate all those stuff and connect everything. And that's why we're gonna have like a manager AI agent, the top level agent that's gonna get the prompts from the users and decide which agents and models are involved, and then respond back to the users or do an action, like for example sending an email. Whew. Well, that might be a lot of information for some of you. I can keep going and adding stuff to this big picture, but it is not fitting anymore. to understand what data engineers does. We are not building apps, we are not building softwares, we are just building data pipelines. Pipeline that pulls the data, clean it, transform it, load it, and keep running every day. Data engineering is like the engine room behind every data-driven company. You are the engineer. You are the one that's gonna go and move, transform, and store massive amount of data. So my friend, that means you are not building a shiny dashboard or you are building front ends. You are as a data engineer behind the scenes, but you go and expose the hidden, complex, important data of the company and you bring it to a suitable platform so that others can do smart things with the data. Okay, so what is a data pipeline? At a very high level, a data pipeline is just a flow. So data comes in from the sources. They go through few steps where we prepare them, clean them, and enhance them. And once they are ready, we're gonna load them into the target table. So it is no rocket science. As a data engineers, we have to build only this, the data pipeline, and we use Python in order to do that. And then other people gonna start using this prepared data in order to build analytical use cases like a dashboard or an AI and some machine learning stuff. This is the big picture of pipeline. And now we're gonna zoom in into each step in order to understand which Python concepts are needed. So now let's start with the first step on the left side. The sources of our data could be in different technologies like databases or stored in files, or maybe they are provided as a stream like using Kafka, and they could live in APIs. So we have different sources of our data, and now the very first step in our pipeline is extract and load. This is where everything starts. So it is very simple. We have to connect to the sources, start reading the data, and then loading it into our system. So we are just taking one copy of our data and putting it in our system. No big smart thing, no transformations. So now in order to do this step in the pipeline, we write a Python script. Okay, so that's all about the first step. We didn't do something smart. We just focus on how to get the data in. Now, the next step is all about cleaning up the data and enhancing it. So what we're gonna do, we're gonna take this raw copy of the data that is messy. We're gonna start fixing it, handling missing value, removing duplicate, and doing small enhancements on top of it. And of course, we're gonna do this step by writing as well a Python main script. And as well, we're gonna have the same add-ons where we're gonna have a config file, a logging, a data quality, and so on. Okay, so now so far what you have done, the first step, we just brought the data in. The second step, we just cleaned up the data. And now moving on to the last step inside our pipeline, here we can apply the business logic and the fun starts. So we're gonna take the data that is clean and start joining it together, doing some data aggregations, and start applying the business logic, the business data transformations. And of course, for this, the same thing gonna happen. We're gonna write main Python scripts in order to do this step, and we're gonna have on top of it some add-ons like the config files, the logging, and the data quality. So as you can see, as data engineers, our job is not that hard. We just have to build this data pipeline where it has mainly three steps. The first one is extract and load. So we're gonna bring the data from the sources into our system without any extra logic or transformations. And now the next step, we're gonna take the raw data and start cleaning it up and enhance it. So we're gonna fix the data type, we're gonna clean the text, we're gonna handle the dates, and make sure everything is prepared for the last step where we're gonna transform and apply the business logic. So we're gonna join the tables, aggregate the data, apply the rules, and prepare a final product for the analytics and as well for AI use cases. In any industry or business, everyone at the top had the same mission. Managers, stakeholders, project leads all need to make smart decisions, and they need to make them fast. And they ask questions like which region is falling behind, why profits are dropping in the last month, and where they should put their money next. And those are real critical business questions, and they need answers. So now if they try without a good data, they are going to guess. So they're gonna use opinions and some gut feelings in order to answer them. Deming said it best: without data, you are just another person with an opinion. That's why most of the companies, they gonna try to answer the data using the company's data. And for that, the business gonna hire a data analyst in order to find the answers from the data. But to do that, they need a tool, and if the company doesn't have the right one, they usually go and use spreadsheets like the Excel files. So the analyst gonna try to go and collect the data from the sources and put it in the Excel files. They're gonna clean up the data, fix mistakes, and prepare the data so that at the end they're gonna present the answers using numbers and charts to the managers, and after that the manager gonna use them in order to make critical business decisions. So now this sounds like happy ending, right? Everyone is happy and we got the answers. But in real world, this doesn't work like this. If you are using spreadsheet or Excel to do data analysis, things gonna start to fall apart. Let me show you what I mean. Now the entire process is manual, so you are connecting the sources, exporting files, merging sheets, cleaning rows. People think it is easy, but in reality this is painful and it takes a lot of time. Sometimes it takes weeks, and I have seen cases where it takes months. And if it takes a lot of time to present the data, that means the data inside the reports are actually old, which means the managers are making decisions based on old data, and the business might have been changed in the last week and no one knows about it because we have old data inside the Excel files. So that means managers makes decisions based on outdated data, and this might result to bad decisions, which gonna cost the company a lot. So the new generated data inside the systems will not be automatically updating the charts or whatever results that you have in Excel. It's gonna be like snapshot static. Another issue is that the company's systems are not always like a simple database or files. Now the systems lives in cloud, they provide data in APIs, or even they stream their data in platforms like Kafka. And pulling the data from those modern systems into Excel by hand is almost impossible. So you're gonna struggle with the modern technology. Another big issue as well, the sources now are generating massive amount of data. So if you try to export everything to Excel and put it in file, at some point your Excel file is gonna explode and maybe freeze or crashes. They simply can't handle real big data. And another one can be funny to watch if the company decide to speed up the process by adding more people to the project. So you're gonna have more than one analyst that they're gonna try to prepare this Excel file, and guess what? They cannot work inside the same file at the same time. And the solution for that, each one gonna go and create their own copy. So that means you're gonna have multiple versions of the same file, and good luck merging all those stuff back to one file. And another big issue using Excel files is the security. So the analysts or the managers might send the Excel files through emails, and those files could be storing sensitive data about the company, and it is really easy to hack the Excel files to get access to them, and could be easily end up in the wrong hands. So your company's data are totally unprotected if you put it in spreadsheets. And another thing about the security, not all the data inside the Excel should be available for everyone in the company. Sometimes part of the data is really sensitive and only upper management in the company are allowed to see it, not everyone in the company. So in Excel you cannot go and apply something called row level security to control which department or which people are allowed to see the data. So you're gonna end up creating multiple versions for multiple departments. And now since we are talking about departments, we come to the biggest issue, the biggest catastrophic. Different departments like sales, finance, marketing have their own analysts. So one analyst is exporting the data, cleaning up, and then they build their own formulas. And guess what can happen if you leave it like this? First, people are spending their mornings doing the same task, and now if the managers ask the same question to 3 different analysts, they're gonna get 3 different answers. It's not because they are wrong, it is because of this whole system. One file is 2 weeks old, another one is 1 week old, and another just got updated yesterday. And as well, the calculation in each file could be slightly different. So that means, my friends, it is big confusion and there is no more single point of truth for the data. And my friends, to be honest, I have seen this almost in every company that I have joined. It is total disaster and pure chaos. And that's why many of the companies, they understood they cannot rely on spreadsheets to do data analysis. Instead, they need a standard, they need a process, platform to do the whole thing in one place. And we call this process, this system, as a business intelligence, or as a shortcut, BI. So what is that? A business intelligence is the whole process of working with data. So collecting the data from the sources, cleaning up the data, preparing and organizing it, and then turn it into into visuals so people can understand what is going on and make better decisions. So the BI, the business intelligence, is the full workflow from start to finish. A lot of people think business intelligence is just like making charts and dashboards. Well, it is way more than that. And of course, we need tools, platforms to do now the business intelligence, right? And for that, we have two very famous platforms. We have the Tableau and the Microsoft Power BI. And that's why you have it in the name, Power BI, BI Business Intelligence. That's why we call Power BI as a BI tool. Same thing goes, of course, for Tableau. Now, quickly, what is the history of Power BI? Because Power BI didn't start as a giant platform, everything began inside the Excel. So Microsoft has tools like Power Query and Power Pivot hidden inside Excel. Those tools were very powerful, but the thing is, Excel itself was not able to handle the big modern data, as I showed you all the issues and problems of the Excel. And at the same time, other platforms like Tableau start to becoming very popular because it offered a clear way and easy way to do data visualizations. So that's why Microsoft understood they need something completely new. They cannot keep adding stuff to Excel. They start taking the strong parts of Excel and turn them into new products focused on data analysis. And that idea became Power BI in 2015. And since that point until now, Microsoft keep pushing and keep improving the Power BI month after month. Better visuals, more connectors, improving the performance, deep integration of Power BI with the Microsoft ecosystem, and in the last 4 years they introduced the Microsoft Fabric and copilots in Power BI. So over the time, Power BI grew into a full business intelligence platform or a data analytics platform. It became one of the Tableau's main competitors. Both of them are now the top tools in the world for BI. If you have a look at Google Trends, you can exactly see the clear shift. Tableau was dominating for a long time, but Power BI kept growing and growing until we reached the point where Power BI gets searched almost as much as Tableau worldwide. So it is interesting where Power BI and Tableau gonna go over the time. And for Power BI, we have another name. We call it as Data Visualization Tool. So what is that? But first, let's have some coffee, right? Alright, so it is the process of turning raw data and boring numbers into visuals and charts like bar, line, pie charts and heat maps, just to make it easier for humans to understand the complex raw data instantly. Because, my friends, we are visual creatures. If you see a picture of a tree, you're gonna understand it right away. But if you read the word tree, your brain has first to process it and turn it into visual. So that means visuals skips these extra steps, which makes it easier for your brain. So that means visuals are processed way faster than reading a text or looking to numbers. And not only that, our brain remember them longer. So we keep small part of what we hear, a bit more of what we read, but most of what we see. So this is the power of visuals, and data visualizations are very powerful because you understand the information faster, you see the patterns and problems instantly, you can use them to explain your ideas, you can tell a story, and with that the others can make better decisions. And everyone gonna remember the visuals way longer than numbers. And exactly for that, tools like Power BI focuses on data visualizations. So now the question is, what is inside Power BI and how it actually works? It is divided into 5 components and each one of them has its own clear job. The first one is Power Query. This is where you clean up your data. You remove mistakes, duplicates, you fix the formats. So it's all about preparing the data. The second component is the data module. Once everything is cleared, it's time to structure and organize your data. So it's all about how you go and connect your tables to each other's, and this is very important to make everything accurate, organized, and as well fast. Now moving on to the next one, we have the DAX. Everyone is afraid of this one. So DAX is all about using calculations and math in order to build the business logic that you're gonna need for the next step. So everything so far is like hidden. It's the background of the Power BI, no one sees it. And now it's the first time you're gonna build something that the end user is gonna see, the visuals. So here you're gonna build all those charts and big numbers, tables, and those filters, and the dynamic of everything, just in order at the end to tell a story using the data. Now, once everything is ready, you go to the last component in order to share and publish what you have built. So at the end, people gonna view your report, interact with it, and make decisions. So those are the 5 components and blocks inside Power BI that you have to use in order to build something in Power BI. So it looks like a process, a simple pipeline. You bring the data in, you clean it, you module it and organize it, then visualize it, and at the end you share it. And you can do the whole thing in just one platform, the Power BI. So now let's talk about the Power BI ecosystem, because Power BI itself, it is not just one thing, it is multiple things. So Microsoft offers multiple tools and each one of them has its own job. The first one is the Power BI Desktop. This is the app that you install locally on your PC, and I have bad news, just to make it clear, you cannot install it on Mac because it is Windows only, unless you are using some extra workarounds. So the Power BI Desktop is where you spend most of your time building things. It is basically the engine of Power BI. Everything that you have talked about inside this tool, the Power Query, the data module, the DAX, the visuals, the whole thing, the whole process is inside this one tool, and everything, the data, the modules, the reports gonna be stored into one single file locally at your PC, and the extension of this file gonna be PBIX. And of course you can go and share this file directly with the others, but we don't want to have another Excel's issue, right? We don't do that. Instead of that, we're going to publish everything that we have built to a new tool, to the next part of the ecosystem, the Power BI service. And at this point, once you publish your report from desktop to the service, your report now gonna live there. Now what gonna happen? Your end users, your consumers gonna open their browser and start viewing your reports and dashboards and interact with them. So they can start filtering things, checking the number and whatever they need. And of course, if you have some top managers that don't have the time to open their laptops, no problem. This is totally fine because they can go and install the third tool, the Power BI app, on their phone or tablet in order to connect to the same reports that lives in the cloud, in the service. So using their devices, they still can interact with your report. Of course, there are a lot of more extra stuff, but those are the 3 major, let's say, tools that Microsoft offers. A desktop where you build things, the Power BI service where you're gonna host and share your reports, and this nice Power BI app to interact with your stuff using phone and tablets. Now, you might ask, is Power BI only made for data analysts? Because we have understood it is their main tool. They use it in order to answer business questions using data and visuals. So if I am not data analyst, if I do something else, should I learn Power BI? Well, my friend, of course. Like for example, me as a data engineer who go and build data pipelines, I still go and use Power BI in order to make dashboards to monitor my system, to check the data quality and make sure that everything is loaded correctly the way it should. So I use Power BI to monitor internally the whole system that I'm building as a data engineer. Now as well, you can use it as a data scientist. So you go and build models, predictions and machine learning solutions, but still as a data scientist, you have to go and share your work with non-tech and business users, and you cannot share with them your code or notebooks. You're gonna go and use Power BI to share your work because it is simple and easy for business users. So it is the best way to explain the complex things that you do as a data scientist. And of course, if you are a business analyst, you're gonna end up as well using Power BI. So you're gonna use it to answer what happened, why it happened, and what should happen next. So you use insights for conversations and discussions. And by the way, not only at work, I know a lot of people that use Power BI for personal life at home. They use it in order to track their spending, for budgeting, for investments. Anytime you have numbers and you would like to make visuals, you can use Power BI. So for example, I use it for YouTube stuff to analyze and track things. It just works for everyone. And now, my friends, there is like an endless war about which BI tool is better, Power BI or Tableau. I saw this topic discussed everywhere at YouTube, social media, and at companies. There are endless content and meeting and efforts about it. And now, if you ask me which one should I use or which one is better, I'm gonna tell you both are good. And there is one of the projects that I have done that I utilized both of them, Power BI and Tableau, at the same time. So now I'm gonna tell you a few reasons why some teams tend to use Power BI instead of Tableau. The first and obvious reason is it fits your daily tools. Most of people at work already use Microsoft products like Outlook, Teams, Excel, PowerPoint, SharePoint, and Power BI feel natural because it fits. It looks like Excel, it looks like PowerPoint, and it is already connected to all those tools without any extra steps. The second reason, it is very easy to switch from Excel to Power BI. Because you already know DAX, the interface looks like an Excel, and the charts and dashboards look similar. You have already the background to switch to Power BI. Reason number 3, it is more affordable. Power BI costs less than other tools. And now, my friend, of course, all the companies are trying to cut costs. And one of the major costs in each budget is actually licenses. This is a winning factor why they utilize Power BI. And another reason, inside Power BI you have a lot of things like the data cleanup and preparation using the Power Query. Many other platforms like Tableau, they offer like a second tool like Tableau Prep in order to prepare the data. But with the Power BI desktop you have like everything in one place, which makes it easier for you not to jump between like tools to do the whole process. And another reason why people tend to use Power BI is that Microsoft really focuses on this tool. Like there is a new release and new updates every single month. New visuals, new features, new connectors. The tool is really keep growing very fast. And another reason, which is my favorite one, the data modeling inside Power BI is really strong. So there are a lot of features and advanced stuff that you can do as you are modeling the data. If you compare to Tableau, Tableau is really limited on how you build the data model, which is a clear win for Power BI because if you have a strong data model, you can make very flexible and fast insight with the Power BI. So those are the reasons why we use Power BI instead of other tools like Tableau. But the major reasons are, again, it is cheaper than other tools, it is integrated everywhere in the Microsoft ecosystem at work, and the third one, come on, it looks like a powerful Excel. Everyone is familiar and use Excel. So the interface of the Power BI looks really familiar. So those are my reasons why I think Power BI is becoming very popular and widely used. Okay, so my friends, Power BI is great, but actually not perfect, and there are some scenarios where I'm gonna say Power BI is limited compared to the other tools like Tableau. Like the biggest limitation with the Power BI is you cannot use it for very complex visuals. Now, if you are building operational reports where you have some basic charts, a bar, line, or pie charts, some table and filter, then Power BI is more than enough. But the thing is, if things get a little bit advanced and complex, like if you are a data scientist that is making dot plots or some advanced insights about the data, it is way easier to use Tableau and as well faster. It still stronger and wins here compared to Power BI. And another thing where I cannot use Power BI is that there are limitations. So if you are using scatter charts in Power BI, you are limited only to show few thousands of data points, which is really a disaster if you have a lot of data. You would like even to show hundreds of thousands of data points in order to find those outliers. And Tableau does not enforce any hard limitations or restrictions on the number of data points on the visual. Literally, I had one visual that is showing millions of data points on my dashboard in Tableau. And another reason, which is really annoying, you cannot run Power BI desktop for Mac users. You need always to use workaround where the tools like Tableau, you can install it in both Windows and Mac. So those are the major reasons, let's say, to not use Power BI. And this is exactly why I have utilized in one project both of the tools, Power BI and Tableau. So for basic operational reports and standard reports that goes to managers and leaders, I have utilized Power BI, which is more than enough. And I can tell you 80% of requirements and reports fits into those two categories. And only for complex and advanced analytics that is usually prepared by advanced data analysts and data scientists, we use Tableau because it is faster for big data, and as well you can create highly customized charts. And of course, not everyone in the company did use it, so we give it an access only for like a focused audience that has advanced analytical requirements. So this is my take on why we use Power BI and when not to use it. Alright friends, so that was a whole full introduction about what is Power BI. So what what is exactly SQL? Everything generates data and data is everywhere. Your first name is data, your mobile and everything inside the mobile is data. Car is as well generating a lot of data. Bank, your finance statements, everything is data. And now of course the question is, where do we store our data? Personally, we store a lot of our data in like Excels, spreadsheets, in a text file. So you store a lot of your data in different files. Now how about companies? They have a lot of things that generate a lot of data. That the products that they produce, their customers as well generating a lot of data, and sales informations and a lot of things. So companies generate massive amount of data. So now the big question is how they handle the data, how they store it. Of course they cannot go and use like simple files. They need something bigger, stronger and smarter. And here where the database comes in. So think about the database, it's like a container for storing data. But instead of just dumping files into folders, the database organizes the data so it is easy to access, to manage and to search. So a database simply it is a container that stores data. So now you might ask why we are using database. Can't we just use files like I do it personally? Well, let me tell you why we use databases. Imagine that someone asks the following question: go and find the total spending in your data. So now in order for Mike to find the total spending and the costs, he will be opening each of those files one by one, searching for the costs, trying to combine the data, and it's gonna be very long and messy process. But now in the other side, if your data in database and you want to ask a question, it's gonna be very easy. So all what you have to do is to talk to the database, to ask a question, and the database can answer your question with a result. And now comes of course the question, how do we talk to a database? Well, we use SQL. SQL is the language that you use in order to talk to the database. It stands for Structured Query Language, SQL. And here you have people that call it SQL like me, and others that call it SQL. There is no right and wrong, but if you follow me through the course, I think you will start saying SQL. So by using SQL, you can ask the database, you can ask your data, and the database can answer your question by sending you a result. So this process is very easy, simple and fast, and this is way better than having your data stored in different files. Another reason why we use databases is that they can handle really huge amount of data. So sometimes we have like millions of data inside our database, but on the other side, if you are storing your data inside spreadsheets and you have like massive amount of data, what can happen? Your spreadsheet's gonna just break. They simply can't handle big data. And another reason why we use databases is that it is just secure. It is safer to store important and critical data inside a database than just storing it in spreadsheets and files. So the databases are secure and you can control who is accessing what. So it is just more professional to store the data inside a database. Alright my friends, so far what we have learned, most of the companies stores their data inside a container called a database, and for you in order to ask questions and to talk to your database, you have to speak the language of SQL. Now I'm going to show you how it looks like usually in companies. So we have our data inside the database, and then you will have multiple people with multiple roles that are just writing different SQLs in order to talk to the data. But now not only employees and people interact with the database, you could build a website or an application that as well interacts with the database by sending different SQLs. And of course, depend on how many people are interacting with the application and the website, it might generate really massive amount of SQLs that sends to the database. And not only that, you might have as well tools in order to do data visualizations where you have like a dashboard or a report, maybe created using Power BI or Tableau, and it is used by stakeholders and managers in order to make decisions. And as well, those tools will be connected to the database and creating SQLs. So now as you can see, we have a lot of interactions with the database, from people, applications, tools. A lot of things are generating SQLs and interacting with the database. But the database is just a container and storage, right? So we need something, a software that manage all those requests. And that's why we have something called Database Management System, DBMS. So it is a software that gonna manage all those different requests to our database, and it's gonna make the priority which SQL must be executed first. This software can as well manage the security, whether the SQL is allowed to be executed in the first place, database. So my friends, the DBMS is the software that gonna manage the database. And now we are not done yet. There is something missing. So we have our data, we have the software. What is missing here is the hardware. So in real companies, we cannot run that on our PC because first our PC is weak and as well it goes offline. That's why we need a server. Server, it is like a very powerful PC and as well it lives 24/7. So it is always available. And here we can decide whether we're gonna have a server inside the company or we can use cloud services in order to run our database. So my friends, so far what you have learned. The database, it is container to store the data. The SQL, it is the language in order to talk to the database. The DBMS, it is the manager, it manages the database. And the server, it is the physical machine where the database lives. So this is how it looks like. And now my friends, there are different types of databases. So let's see what do we have. The first and the most famous one, it is the relational database. It is very simple. It is like spreadsheets, call them table, where we have columns and rows. And then there is like a relationship between those tables to describe how they relate to each other. And that's why we call it relational database. So if people hear a database, they're gonna think about this one. Now we have another type of databases called key value. This time the data is organized completely different, where you have pairs of keys and values. Think about it, it's like a big dictionary where you have a word like the key and the definition of the word. This is the value. And now moving on to the next one, this is as well important, column based. So now instead of grouping the data by the rows, this type of databases group the data into columns. That's why it's called column based, and this is very advanced database in order to handle huge amount of data where the main purpose is to search for data. Moving on to another database called graph database. The main focus here is the relationship between objects. So the main idea here is how to connect my data points. And now finally we have the document database. The data is stored as entire documents, where the structure of the data is not that important. What is more important is to fit everything in one page, in one document. And now if you look to those 5 types, we can group the document, graph, column-based, key value, all those databases called NoSQL databases, and the relational database, SQL database. And in this course, we will be focusing, of course, on the relational database. And I'm sure you have heard about like the Microsoft SQL Server, the MySQL, the PostgreSQL. All those databases, they are SQL relational database. And for the key value, you have the Redis, the Amazon Dynamo DB. And we have for the column based, we have the Cassandra and the Redshift. For the graph database, we have the Neo4j and the very famous database, the MongoDB as a document database. Now, my friends, for this course, we're going to be focusing on the SQL relational databases because it is the most famous one and the most used one in companies. And I will be focusing on the Microsoft SQL Server. So those are the different types of databases. Now the databases are very structured and organized. It has the following hierarchy. The starting point is the server. As we learned, it is powerful PC and it is where the database lives. And inside it, we can have multiple databases. So maybe you have a database for the sales and another one for the HR. So the server can host multiple databases. And as we learned, a database is a container of your data. Now moving on to the next level, in each database, we can have multiple schemas. A schema, it is like category, or you can call it a logical container that we can use it in order to group up related objects. Like let's say you have hundreds of tables, so you can split all the tables that has to do with the orders in one schema, and then another group of tables with the schema customers, and so on. So it helps you to organize your tables and your objects in the database. And now if you go inside the schema, you can have multiple objects like tables. So now of course the question is, what is a table? It is like spreadsheet. It organizes your data into columns. The column define the data that you store inside it. So you have one column about the customer ID, another column about the names, the scores, the birthday. So each column is about one type of data. And sometimes we call the columns as fields. Now the other thing that you have in tables is the rows, or sometimes we call it records. It is where actually the data is stored. Now in this example, each record represents one customer, one person. So we have one record for Maria, John, and Peter. Those we call them rows. Now in each table there is like one very important column called called the primary key. It is always very important to have like one unique identifier for each customer, for each row, and we use it for different purposes in order to combine it with another table, in order to identify quickly one customer. So it is unique, it's like fingerprint, and there is no two customers having the same ID. Now the overlapping between the columns and the rows, we have a single value, a cell, and each value, each column stores a specific data type. A data type, it is like what kind of data we are storing, like an integer 1 to 30, or a decimal where you have a decimal point 3.14. Now, if you want to store characters, we have different data types for that. Like you want to store the name or the description. So here we can use the char or the varchar. So you store inside them like the first name Maria or something. Now you might ask, what is a char or varchar? So the char always a fixed one. So if you define it like 5 characters, always it's gonna go and reserve 5 characters from the space. But if you want things more dynamic, then you go with the varchar. And now moving on, we have another data types called the date and time. So if you want to store a date like the birth dates, and if you want to store the time information, you can use the time data type. So we call those stuff int, decimal, char, date, time. They are data types. So my friends, as you can see, SQL databases are very organized and structured. Okay, so now let's focus more about the SQL itself. We have in SQL different type of commands. So let's say that we have a database and this database is empty. So we have nothing inside it. Now, of course, the first thing that you have to do is to write an SQL with the command create in order to create a brand new table in the database. So once you execute it, the database is going to go and build one, but this table is empty. So we have nothing inside it. So now what you have done here is you have defined something new, right? And we call this type of commands the data definition language. The DDL. We have create to create something new, alter in order to edit something that already exists, and drop in order to delete something, to drop, for example, a table. So this is the first family of commands. Now, if you look at our table, it is empty. What do we need? We need data. So let's say that we have a website or an application. Now, this application is generating a lot of data. Now, in order for this application to move the data inside our new table, it must use the SQL command insert. So if you execute insert, you can add a new data inside your table. This type of commands, we call it data manipulation language. And here we have 3 commands: insert in order to insert a new data, update in order to update an already existing data, and delete in order to go and delete data from your table. And that's why we call it data manipulation language, because you are manipulating your data. So what do we have now? We have table, we have data inside the table. Now what we can do, we can start asking questions. So let's say that you have an analytical question about your data. Now all what you have to do is to write something called SQL query, and inside it you use the command select. But the whole thing, we call it a query. So you send a query to the database, you have a question, and the database can return for you the result, the data answering your query, your question. And we call this type of activities using SQL the data query language. And here we have only one, and it is very famous. We have the select. We can use it in order to query our data. So those are the 3 different commands in SQL, and of course we're gonna learn all of them, but we will spend most of our time learning how to write the correct query for the correct answer. And now you might ask me, Bara, why we have to learn SQL? And if the time goes back, are you going to learn SQL again? Well, for sure, of course. And here are the top 3 reasons that I have. The first one, you have to learn it in order to talk to the data. You know, most of the companies stores their data in databases, and this is a standard way. This is how they do it. And if you want to work on the company in the data field and you want to talk to their data, then you have to use SQL. It's like you move to another country where they speak another language and you want to live there for a long time, you have to speak their language. The same thing here. If you want to work with data, you have to learn the language in order to speak to the database, the SQL. So this is for me the most important reason why we have to learn SQL. And SQL, it is in high demand. If you go now and check the job description of the software developer, data analyst, data engineer, data scientist, I promise you, you will find there that they're gonna demand for SQL. So you will find they're gonna ask for SQL skills almost in each job description. So if you check for any data related jobs, you will find that they're gonna ask for or SQL skills. Now, another reason that I have is it is industry standard. So if you go and check multiple modern data platforms and tools like Power BI, Tableau, Kafka, Spark, Synapse, you will understand that there will be always a section where you have to enter SQL code. So most of those vendors adopt SQL because it is the standard, it is widely used. It is like selling points that their tools are easy. So those are my top 3 reasons why SQL is still relevant and why you have to learn it. Okay, my friends, so with that we have now clear understanding what is an SQL, why we need it, what are databases and their different types, why do we have DBMS, servers, and as well now you have understanding how things are very organized and structured inside the databases. So that's all. This is SQL. Okay, so now let's start with basics. What is programming language? So now imagine that you want to give your computer a task and you say, hey computer, calculate 5 plus 5. Well, your computer will not understand what is exactly you are talking about and nothing gonna happen. So we cannot use the natural human language in order to give tasks for your PC. So now instead of that, we have to give the instructions in a language where the computer understands it. We write a short piece of code, like for example here in Python, print 5 plus 5. Now the computer gonna understand the instruction and give us as a result 10. So a program, it is like set of instructions that is written in a language the computer can follow. But my friend, not all languages are the same. Some are made for people and others are made for machines. So now at the top we have the natural language. Like you say, hey, please calculate 5 plus 5. And we have a lot of natural languages. We have the English, Spanish, Hindi. They are easy for us but far too complex for computer to understand. Now moving on, then we have the high level languages. So they are programming languages, but they are made for human because they are very simplified, logical, and really easy to write and to read. And we have a lot of languages like Python and JavaScript. They are high-level languages. And now next we are going lower. We are going to the low-level languages. Programming languages can talk directly to the machines, but they are really hard for humans. It's hard to read, to write, and as well to understand. And here we have examples like the assembly and the C language. And now at the very bottom we have the machine language, and this one is made of binary code, a combination of ones and zeros, and this is exactly what your computer can understand, but it is impossible for humans to read it, to understand it, to write it. So now if you look at these levels, each step down it's gonna bring us closer on how the machine thinks, and each step up it's gonna bring us closer on how human thinks. So now if you're looking at Python, the high level language, it is closer to the natural language than the machine language. So that means it is really easy to learn and to write, and it's like an abstraction that hides the complexity of low-level and machine languages. So it's like a bridge between both worlds. So this is exactly what are programming languages and what is Python. Okay, so now I would like you to understand exactly how Python works. So let's say you open your editor and you start writing Python code. And usually we write the code inside a Python file with the file extension of py. So here you are writing the source code. Once you run your code, the computer cannot immediately execute your instructions because it is really high level and the computer needs a lower level of the code. So what happens? There is something called compiler in Python. It's gonna take your Python code and translate it to another code. It's called the bytecode with the extension .pyc, Python compiled. And this can happen automatically and you will not even notice it. So what happened here? The compiler of Python gonna translate the high level language, the Python code, to a low level language, the bytecode. So as you can see, it's really hard to understand the bytecode compared to the Python code. So now our code is not yet executed, right? Python just did a translation. But now before anything to be executed, what's gonna happen? Python might as well link some libraries. It is like pre-written chunks of code that helps your code to do something specific, like working with files, handling data, and so on. Now Python has everything, the bytecode, the libraries, and now Python can run your bytecode using something called Python virtual machine. So it's like a software that can understand the bytecode of Python and take care of running it. So the Python virtual machine gonna finally convert your instructions into machine code, ones and zero, because this is the only thing that your computer can really understand. And once it's run, you will see as the results whatever your program was designed to do. And now all those 3 steps, compile, translate, and execute, we call them the Python interpreter. So it's like a toolbox that handles everything needed to run a Python code. So again, my friend, You write Python code in a high language, then Python compiles it and translates it into the bytecode, the low language, and then the virtual machine gonna take care of everything, gonna take your bytecode, some libraries, and then it's gonna run it at your computer to see the results. So this process happens every time you run a Python code, and everything is of course automated and behind the scenes. Okay, so now let's talk about why we should learn Python in the first place. There are like too many programming languages out there, so why millions of people choose Python? So the first and most important reason is Python is very powerful and as well at the same time very simple. You can build really serious stuff with few lines of codes. So if you compare like Java and Python, in Java or C++, you're gonna write like a lot of lines in order to do a simple task compared to Python where you need only like 1 or 2 lines. So as you can see, Python is very simple compared to other programming languages. Okay, moving on to the second reason, Python is used literally everywhere and you can use it in order to build everything. So you can use it to build websites, to automate tasks, to work with data, to build games, and even control robots. So whatever direction you want to go in tech, you will find probably Python. Okay, moving on to the next one. One of the best things about Python is the community. You are, my friend, never alone. There are thousands of developers and experts like me sharing their knowledge in tutorials, or they are like writing blog posts and as well developing and sharing free libraries, open source projects in GitHub. And if you are stuck or have any complex task, I'm sure there is like someone already solved it and probably made a YouTube video or a GitHub repo about it. So this type of community makes the language alive. And when it comes to AI, Python is leading the way. Almost everything you hear about today like ChatGPT, image generations, self-driving car models, it's built with Python because Python has an incredible ecosystem for AI and machine learning. So my friends, that means the programming language of AI is Python, and if you are interested in the future, then Python is the right language. And now because of all these reasons, Python is one of the most in-demand programming language in the world right now. If you check any job description in the tech world, you will see everyone across all industries, finance, healthcare, logistics, car manufacturing, everyone is requesting Python skill. So my friends, Python is really easy to learn, has incredible use cases, it is shaping the future with the AI, it has huge community, and it is amazing for your career. So this is exactly why millions learns and works with Python. Okay, so now I hope that I got you motivated to learn Python, and I will not leave you there. I'm gonna show you now how to learn Python. So Python is like a journey, and every journey needs a roadmap. So now everybody gonna start from the same place. Every expert, a data engineer, AI, web, gaming developers, everyone has to start at the same place. Everyone has to learn how to write a simple code, understand variables, how to work with data types, how to control the flow of your codes, and as well you have to learn about the functions and how to organize your code into small reusable blocks. So this stage builds your foundation, and now after that everyone has to go to the intermediate level. Now we're gonna level things up. You're gonna start learning how to handle errors and exceptions, how to structure your code using the OOP, object-oriented programming, how to split your projects into modules, and how to work with files and many other stuff. So at this phase you start feeling how your code is getting more professional, more like a real developer. So things gonna make more sense here. And now after that everyone gonna start moving to the advanced level, and here you can start learning advanced techniques. We're gonna go outside of our code in order to connect ourselves with APIs, in order to grab data from the internet, and we're gonna learn stuff like how to test your codes and how to scrap website to collect data automatically. And at this level you're gonna start doing real projects and solving real problems. So now as you can see, all those 3 levels, they are the core of Python, and everyone must learn these techniques because everyone needs those techniques in whatever you are building in the future. And now after that, of course, we cannot keep learning everything. It's gonna be really impossible. So you have to really make thoughts about which path you want to follow, the direction that match your interest and your career goals. So you have to pick your path. And there are like a lot of options. Like for example, you could be a data engineer. If you'd like to work with pipelines, automations, moving data around, then you have to learn something like PySpark, ETL processes, and automations with Python. Another path, you can use Python for data science. If you enjoy working with data, charts, insights, if yes, then you're going to be working with libraries like Pandas, NumPy, and Plotly in order to analyze and visual your data. If you want to go deeper and build smart systems and models, then you have to work with Python libraries like PyTorch, Transformers, and TensorFlow. And another option and path, you could use Python for web development. So if you want to build websites and web apps, then you can use Python libraries and frameworks like Flask, Django, and Requests. And of course, not only those four, we have a lot of other options like using Python for game development. But as you can see at the expert level at the right side, it's gonna be almost impossible to learn all those libraries. So now if I look to this and tell you about my journey, so I learned everything in Python about data engineering, and then with the time I start picking few libraries from the other options. Like from the data science, I learned the Plotly and the Pandas, and from the AI and machine learning, the Transformers. So I'm gonna recommend you to pick first a path, make yourself an expert there, and with the time start exploring the other stuff. So if you are new to Git, don't worry about it. It is simpler than it sounds. So it's all about to have a safe place where you can put your codes that you are developing, and you will have the possibility to track everything happened to the codes. And as well, you can use it in order to collaborate with your team. And if something goes wrong, you can always roll back. Now, designing the data architecture, it is exactly like building a house. So before construction starts, an architect's gonna go and design a plan, a blueprint for the house, how the rooms will be connected, how to make the house functional, safe, and wonderful. And without this blueprint from the architects, the builders might create something unstable, inefficient, or maybe unlivable. The same goes for data projects. A data architect is like a house architect. They design how your data will flow, integrate, and be accessed. So as data architects, we make sure that the data warehouse is not only functioning, but also scalable and easy to maintain. And this is exactly what we will do now. We will play the role of the data architect, and we will start brainstorming and designing the architecture of the data warehouse. So now I'm going to show you a sketch in order to understand what are the different approaches in order to design a data architecture. And this phase of the projects usually is very exciting for me because this is my main role in data projects. I am a data architect and I discuss a lot of different projects where we try to find out the best design for the projects. Alright, so now let's go. Now the first step of building a data architecture is to make a very important decision to choose between four major types. The first approach is to build a data warehouse. It is very suitable if you have only structured data and your business want to build solid foundations for reporting and business intelligence. And another approach is to build a data lake. This one is way more flexible than a data warehouse, where you can store not only structured data but as well semi and unstructured data. We usually use this approach if you have mixed types of data, like database tables, logs, images, videos, and your business want to focus not only on reporting but as well on advanced analytics or machine learning. But it's not that organized like a data warehouse. And data lakes, if it's too much unorganized, can turns into data swamp, and this is where we need the next approach. So the next one, we can go and build data lake house. So it is like a mix between data warehouse and data lake. You get the flexibility of having different types of data from the data lake, but you still want to structure and organize your data like we do in the data warehouse. So you mix those two worlds into one, and this is a very modern way on how to build data architecture, and this is currently my favorite way of building data management system. Now the last and very recent approach is to build a data mesh. So this is a little bit different. Instead of having centralized data management system, the idea now in the data mesh is to make it decentralized. You cannot have like one centralized data management system, because always if you say centralized, then it means bottleneck. So instead you have multiple departments and multiple domains where each one of them is building a data product and sharing it with the others. So now you have to go and pick one of those approaches, and in this project we will be focusing on the data warehouse. So now the question is how to build the data warehouse. Well, there is as well 4 different approaches on how to build it. The first one is the in-one one approach. So again, you have your sources, and the first layer, you start with the staging, where the raw data is landing. And then the next layer, you organize your data in something called enterprise data warehouse, where you go and model the data using the third normal format. It's about like how to structure and normalize your tables. So you are building a new integrated data model from the multiple sources. And then we go to the third layer, it's called the data marts, where you go and take like small subset of the data warehouse and you design it in a way that is ready to be consumed from reporting. And it focuses on only one topic, like for example, the customers, sales, or products. And after that, you go and connect your BI tool like Power BI or Tableau to the data marts. So with that, you have 3 layers to prepare the data before reporting. Now moving on to the next one, we have the Kimball approach. He says, you know what, building this enterprise data warehouse, it is wasting a lot of time. So what we can do, we can jump immediately from the stage layer to the final data marts, because building this enterprise data warehouse, it is a big struggle and usually waste a lot of time. So he always wants you to focus on building the data marts quickly as possible. So it is faster approach than in one. But with the time, you might get chaos in the data marts because you are not always focusing on the big picture, and you might be repeating same transformations and integrations in different data marts. So there is like trade-off between the speed and consistent data warehouse. Now moving on to the third approach, we have the data vault. So we still have the stage and the data marts, but it says we still need this central data warehouse in the middle, but this middle layer, we're gonna bring more standards and rules. So it tells you to split this middle layer into 2 layers, the raw vault and the business vault. In the raw vault, you have the original data, but in the business vault, you have all the business rules and transformations that prepares the data for the data marts. So data vault, it is very similar to the in1, but it brings more standards and rules to the middle layer. Now I'm gonna go and add a 4th one that I'm gonna call it medallion architecture. And this one is my favorite one because it is very easy to understand and to build. So it says you're gonna go and build 3 layers, bronze, silver, and gold. The bronze layer, it is very similar to the stage, but we have understood with the time that the stage layer is very important because having the original data as it is, it's gonna help a lot by traceability and finding issues. Then the next layer, we have the silver layer. It is where we do transformations, data cleansing, but we don't apply yet any business rules. Now moving on to the last layer, the gold layer. It is as well very similar to the data marts, but there we can build different type of objects, not only for reporting, but as well for machine learning, for AI, and for many different purposes. So they are like business ready objects that you want to share as a data product. So those are the 4 approaches that you can use in order to build a data warehouse. So again, if you are building a data architecture, you have to specify which approach you want to follow. What is exactly a data warehouse? Why the companies try to build such a data management system? So now the question is, what is a data warehouse? I will just use the definition of the father of the data warehouse, Bill Inman. A data warehouse is subject-oriented, integrated, time-variant, and non-volatile collection of data designed to support the management's decision-making process. Okay, I know that might be confusing. Subject-oriented, it means data warehouse is always focused on a business area, like the sales, customers, finance, and so on. Integrated because it goes and integrate multiple source systems. Usually you build a warehouse not only for one source, but for multiple sources. Time variance, it means you can keep historical data inside the data warehouse. Non-volatile, it means once the data enter the data warehouse, it is not deleted or modified. So this is how Bill Inman defined a data warehouse. Okay, so now I'm going to show you the scenario where your company don't have a real data management. So now let's say that you have one system and you have like one data analyst has to go to this system and start collecting and extracting the data. And then he gonna spend days and sometimes weeks transforming the raw data into something meaningful. Then once they have the report, they're gonna go and share it. And this data analyst is sharing the report using an Excel. And then you have like another source of data and you have another data analyst that she is doing maybe the same steps, collecting the data, spending a lot of time transforming the data, and then share at the end like a report. And this time she is sharing the data using PowerPoint. And a third system and the same story, but this time he is sharing the data using maybe Power BI. So now if the company works like this, then there is a lot of issues. First, this process, it takes way long. I saw a lot of scenarios where sometimes it takes weeks and even months until the employee manually generating those reports. And of course, what's gonna happen for the users, they are consuming multiple reports with multiple state of the data. One report is 40 days old, another one 10 days, and a third one is like 5 days. So it's gonna be really hard to make a real decision based on this structure. A manual process is always slow and stressful, and the more employees you involved in the process, the more you open the door for human errors. And errors, of course, in reports leads to bad decisions. And another issue, of course, is handling the big data. If one of your sources generating like massive amount of data, then the data analyst gonna struggle collecting the data, and maybe in some scenarios it will not be anymore possible to get the data. So the whole process can break, and you cannot generate any more fresh data for specific reports. And one last very big issue with that, if one of your stakeholders asks for an integrated report from multiple sources, well, good luck with that, because merging all those data manually is very chaotic, time consuming, and full of risk. So this is just a picture if a company is working without a proper data management, without a data lake, data warehouse, data lake houses. So in order to make real and good decisions, you need data management. So now let's talk about the scenario of a data warehouse. So the first thing that's gonna happen is that you will not have your data team collecting manually the data. You're gonna have a very important component called ETL. ETL stands for extract, transform, and load. It is a process that you do in order to extract the data from the sources and then apply multiple transformations on those sources. And at the end, it loads the data to the data warehouse. And this one gonna be the single point of truth for analysis and reporting, and it is called data warehouse. So now what can happen? All your reports gonna be consuming this single point of truth. So with that, you create your multiple reports, and as well, you can create integrated reports from multiple sources, not only from one single source. So now by looking to the right side, it looks already organized, right? And the whole process is completely automated. There is no more manual steps, which of course it reduces the human error, and as well it is pretty fast. So usually you can load the data from the sources until the reports in matter of hours or sometimes in minutes. So there is no need to wait like weeks and months in order to refresh anything. And of course, the big advantage is that the data warehouse itself, it is completely integrated. So that means it goes and bring all those sources together in one place, which makes it really easier for reporting. And not only integrated, you can build in the data warehouse as well a history. So we have now the possibility to access historical data. And what is also amazing is that all those reports having the same data status. So all those reports can have the same status, maybe sometimes 1 day old or something. And of course, if you have a modern data warehouse in cloud platforms, you can really easily handle any big data sources. So no need to panic if one of your sources is delivering massive amount of data. And of course, in order to build the data warehouse, you need different types of developers. So usually the one that builds the ETL component and the data warehouse is the data engineer. So they are the one that is accessing the sources, scripting the ETLs, and building the database for the data warehouse. And now for the other part, the one that is responsible for that is the data analyst. They are the one that is consuming the data warehouse, building different data models and reports, and sharing it with the stakeholders. So they are usually contacting the stakeholders, understanding the requirements, and building multiple reports based on the data warehouse. So now if you have a look to those two scenarios, this is exactly why we need data management. Your data team is not wasting time and fighting with the data. They are now more organized and more focused, and with like a data warehouse, and you are delivering professional and fresh reports that your company can count on in order to make good and fast decisions. So this is why you need data management like a data warehouse. Think about data warehouse as a busy restaurant. Every day, different suppliers bring in fresh ingredients, vegetables, spices, meat, you name it. They don't just use it immediately and throw everything in one pot, right? They clean it, shop it, and organize everything and store each ingredient in the right place, fridge or freezer. So this is the preparing phase. And when the order comes in, they quickly grab the prepared ingredients and create a perfect dish and then serve it to the customers of the restaurant. And this process is exactly like the data warehouse process. It is like the kitchen where the raw ingredients, your data, are cleaned, sorted, and stored. And when you need a report or analysis, it is ready to serve up exactly like what you need. what is exactly an ETL? So our data exists in a source system. And now what we want to do is to get our data from the source and move it to the target. Source and target could be like database tables. So now the first step that we have to do is to specify which data we have to load from the source. Of course, we can say that we want to load everything, but let's say that we are doing incremental loads. So we're gonna go and specify a subset of the data from the source in order to prepare it and load it later to the target. So this step in the ETL process, we call it extract. We are just identifying the data that we need, we pull it out, and we don't change here anything. It's gonna be like one-to-one, like the source system. So the extract has only one task: to identify the data that we have to pull out from the source and to not change anything. So we will not manipulate the data at all. It's gonna stay as it is. So this is the first step in the ETL process, the extract. Now moving on to the stage number 2, we're gonna take this extracted data and we will do some manipulations, transformations, and we're gonna change the shape of those data. And this process is really heavy working. We can do a lot of stuff like data cleansing, data integration, and a lot of formatting and data normalizations. So a lot of stuff we can do in this step. So this is the second step in the ETL process, the transformation. We're gonna take the original data and reshape it, transform it into exactly the format that we need, into a new format and shapes that we need for analysis and reporting. Now finally we get to the last step in the ETL process, we have the load. So in this step we're gonna take this new data and we're gonna insert it into the target. So it is very simple. We're gonna take this prepared data from the transformation step and we're gonna move it into its final destination, the target, like for example data warehouse. So that's ETL in a nutshell. First extract the raw data, then transform it into something meaningful, and finally load it to a target where it's gonna make a difference. So that's it. This is what we mean with the ETL process. Now in real projects, we don't have like only source and targets. Our data architecture gonna have like multiple layers. Depend on your design whether you are building a warehouse or a data lake or a data warehouse. And usually there are like different ways on how to load the data between all those layers. And in order now to load the data from one layer to another one, there are like multiple ways on how to use the ETL process. So usually if you are loading the data from the source to the layer number 1, like only extract the data from the source and load it directly to the layer number 1 without doing any transformations, because I want to see the data as it is in the first layer. And now between the layer number 1 and the layer number 2, you might go and use the full ETL. So we're gonna extract from the layer 1, transform it, and then load it to the layer number 2. So with that, we are using the whole process, the ETL. And now between layer 2 and layer 3, we can do only transformation and then load. So we don't have to deal with how to extract the data, because it is maybe using the same technology, and we are taking all data from layer 2 to layer 3. So we transform the whole layer 2 and then load it to layer 3. And now between 3 and 4, you can use only the L. So maybe it's something like duplicating and replicating the data, and then you are doing the transformation. So you load to the new layer and then transform it. Of course, this is not a real scenario. I'm just showing you that in order to move from source to a target, you don't have to always to use a complete ETL. Depend on the design of your data architecture, you might use only few components from the ETL. Okay, so this is how ETL looks like in real projects. So what is exactly data modeling? Usually the source system gonna deliver for you raw data, unorganized, messy, not very useful in its current states. But now the data modeling is the process of taking this raw data and then organize it and structure it in meaningful way. So what we are doing, we are putting the data in a new, friendly and easy to understand objects like customers, orders, products. Each one of them is focused on specific information, and what is very important is we're gonna describe the relationship between those objects. So by connecting them using lines, so what you have built on the right side, we call it logical data model. If you compare to the left side, you can see the data model makes it really easy to understand our data and the relationship, the processes behind them. Now in data modeling, we have 3 different stages, or let's say 3 different ways on how to draw a data model. The first stage is the conceptual data model. Here the focus is only on the entity. So we have customers, orders, products, and we don't go in details at all. So we don't specify any columns or attributes inside those boxes. We just want to focus what are the entities that we have and as well the relationship between them. So the conceptual data model don't focus at all on the details, it just gives the big picture. So the second data model that we can build is the logical data model, and here we start specifying what are the different columns that we can find in each entity. Like we have the customer ID, the first name, last name, and so on. And we still draw the relationship between those entities, and as well we make it clear which columns are the primary key and so on. So as you can see, we have here more details, but one thing, we don't describe a lot of details for each column, and we are not worried how exactly we're gonna store those tables in the database. The third and last stage, we have the physical data model. This is where everything gets ready before creating it in the database. So here you have to add all the technical details, like adding for each column the data types and the length of each data type and many other database techniques and details. So again, if you look to the conceptual data model, it gives us the big picture, and in the logical data model we dive into details of what data we need, and the physical layer model prepares everything for the implementation in the database. And to be honest, in my projects I only draw the conceptual and the logical data model, because drawing and building the physical data model needs a lot of efforts and time, and there are many tools like in Databricks, they automatically generate those models. So in this project what we're gonna do, we're gonna draw the logical data model for the gold layer. Alright, so now for analytics and especially for data warehousing and business intelligence, we need a special data model that is optimized for reporting and analytics, and it should be flexible, scalable, and as well easy to understand. And for that we have two special data models. The first type of data model, we have the star schema. It has a central fact table in the middle and surrounded by dimensions. The fact table contains transactions, events, and the dimensions contains descriptive informations. And the relationship between the fact table in the middle and the dimensions around it forms like a star shape, and that's why we call it star schema. And we have another data model called snowflake schema. It looks very similar to the star schema, so we have again the fact in the middle and surrounded by dimensions, but the big difference is that we break the dimensions into smaller sub-dimensions. And the shape of this data model, as you are extending the dimensions, it's gonna look like a snowflake. So now if you compare them side by side, you can see that the star schema looks easier, right? So it is usually easy to understand, easy to query, it is really perfect for analysis. But it has one issue with that, the dimension might contain duplicates and your dimensions get bigger with the time. Now if you compare it to the snowflake, you can see the schema is more complex. So you need a lot of knowledge and efforts in order to query something from the snowflake. But the main advantage here comes with the normalization. As you are breaking those redundancies in small tables, you can optimize the storage. But to be honest, who cares about the storage? So for this project I have chosen to use the star schema because it is very commonly used, perfect for reporting, like for example if you are using Power BI, and we don't have to worry about the storage. So that's why we're gonna adopt this model to build our gold layer. Okay, so now one more thing about those data models is that they contain two types of tables, fact and dimensions. So when I say this is a fact table or a dimension table, well, the dimension contains descriptive informations or like categories that gives some context to your data. For example, a product info, you have product name, category, subcategories, and so on. This is like a table that is describing the product, and this we call it a dimension. But on the other hand, we have facts. They are events like transactions. They contain three important informations. First, you have multiple IDs from multiple dimensions. Then we have like date informations, like when the transaction or the event did happen. And the third type of information, you're gonna have like measures and numbers. So if you see those three types of data in one table, then this is a fact. So if you have a table that answers how much or how many, then this is a fact. But if you have a table that answers who, what, where, then this is a dimension table. So this is what dimension and fact tables. Alright my friends, so we're gonna start with a secret, a little trick that I usually do by analyzing any datasets. So let's start with a little coffee before we start. This is really hot. Okay, so the secret says, as I'm looking to any datasets in any project, I see the data always divided between dimensions and measures.
truth.
You take the blue pill, you take the red pill. All I'm offering is the truth, nothing more.
If you see your data like me as dimensions and measures, you can generate like endless amount of insights from any projects, from any datasets. And you will find me through the projects that I'm always speaking about measures and dimensions. So I'm going to show you how I usually do it. So now usually by looking to any datasets in any project, so you have like multiple columns and rows. Here I see the data always split into two categories, either a dimension or a measure. And now of course the question is here, is my column a dimension or a measure? Well, in order to assign it to one of those categories, you have to ask the first question. Is it a numeric value? If it's not, so you have like string or date or any other data type, then it is a dimension. And if it is yes, a numeric, then you have to ask the second question. Does it make sense to aggregate it? So if the answer for both questions is yes, it is numeric and it makes sense to aggregate it, then it is a measure. Otherwise, it is a dimension. Now let's practice and have some examples. So now by looking to the values of the column category, you can see all the values are characters, so it is not numeric. That means this column is a dimension. So it is very simple. Let's take another column. We have the sales amount. So now as you can see, the values are numeric, and as well it makes sense to aggregate those values. We can get the total sales or the average sales and so on. So it fulfills both of the conditions. It is numeric and it makes sense to aggregate it. That's why we say sales is a measure. Now if you're checking the values of the product name, you can see that all of them are characters and names, so it is not numeric. That means the product is a dimension. Moving on to the next one, we have the quantity. The values are numeric and as well it makes sense to aggregate it. You can summarize all those values to have the total quantity, so quantity is a measure. Now if you are looking to the values of the birth date, you can see this is a date information. It is not numeric, so that means it is a dimension, right? But if you calculate the age from the birth date, age of the customer gonna be in numeric and it makes sense to aggregate it. For example, finding the average age of customers. So if we derive a numeric value from a dimension, then we can use it as a measure. So age is a measure. And now we come to something really tricky. This is the ID. So for example, if you are checking the customer ID, you can see all those values are numeric. So the first condition is fulfilled. Now the very important question, does it make sense to aggregate the IDs? Well, those IDs are unique identifier for a customer, and if you find like the average of that, it is not like helpful, right? I cannot think of one use case of aggregating the customer ID, like having the average of all those IDs or summarizing the IDs. So it makes no sense to aggregate it. That's why we can consider the ID of a customer as a dimension, not as a measure. So as you can see, it is very simple. If it is numeric and it makes sense to aggregate, then it is measure. Otherwise, it is a dimension. And this is the foundations of any data analytics. If you see your data as dimensions and measures, you can generate a lot of use cases and insights from your datasets. Now, I totally understand if you are still confused about dimensions and measures, and you might be asking, why do I need measures and dimensions? Well, if you are doing any type of data analysis or you are exploring any datasets, you will end up always like grouping up the data by something. Like you are grouping the data by countries or grouping the data by, for example, products or categories. So we need dimensions to group up our data. And in the other side, you will be asking questions like how much, how many, what is the total of something. So you always need to aggregate or calculate something, right? And for that, you need the measure. So we need the measures in order to answer the question how many and how much. And we need the dimensions in order to group up the data by something. So that's why almost in any type of data analysis, you need dimensions and measures. And this is going to be more clear as we progress in the project. I want to tell you a secret principle concept that each data architect must know, and that is the separation of concerns. So what is that? As you are designing an architecture, you have to make sure to break down the complex system into smaller independent parts, and each part is responsible for a specific task. And here comes the magic. The component of your architecture must not be duplicated, so you cannot have two parts are doing the same thing. So the idea here is to not mix everything. And this is one one of the biggest mistakes in any big projects, and I've seen that almost everywhere. So a good data architects follow this concept, this principle. So for example, if you are looking to our data architecture, we have already done that. So we have defined a unique set of tasks for each layer. So for example, we have said in the silver layer, we do data cleansing, but in the gold layer, we do business transformations. And with that, you will not be allowing to do any business transformations in the silver layer, and the same thing goes for the gold layer. You don't do in the gold layer any data cleansing. So each layer has its own unique tasks, and the same thing goes for the bronze layer and the silver layer. You do not allow to load data from the source systems directly to the silver layer, because we have decided the landing layer, the first layer, is the bronze layer. Otherwise, you will have like set of source systems that are loaded first to the bronze layer, and another set is skipping the layer and going to the silver. And with that, we have overlapping. You are doing data ingestion in two different layers. So my friends, if you have this mindset, separation of concerns, I promise you, you're gonna be a top data architect. Alright, great. So with that, we have a data model, and we can say we have something called a data product, and we will be sharing this data product with different types of users. And there is something that every data product absolutely needs, and that is the data catalog. It is a document that's gonna describe everything about your data model, the columns, the tables, maybe the relationship between the tables as well. And with that, you make your data product clear for everyone, and it's gonna be for them way easier to derive more insights and reports from your data product. And what is the most important one? It is time saving, because if you don't do that, what's gonna happen, each consumer, each user of your data product will keep asking you the same questions about what do you mean with this column, what is this table, how to connect the table A with the table B, and you will keep repeating yourself and explaining stuff. So instead of that, you prepare a data catalog, a data model, and you deliver everything together to the users. And with that, you are saving a lot of time and stress. I know it is annoying to create a data catalog, but it is investment and best practices.
So let's keep it simple. An AI engineer is someone that builds systems that use AI to solve real business problems. So that means you are not building a ChatGPT, or you are not training a data model, you are building an AI system. So what is inside an AI system? You're gonna find the following components. You will be connecting AI models like the OpenAI models from Hugging Face. You will be connecting the company's data, databases, files, documents, and you will be connecting as well the company's tools and apps like emails, some internal services and stuff, and interfaces where the user gonna interact with the AI system. So as you can see, you are just connecting stuff in one place, and your main job is to make everything correct, secure, fast, scalable, and cost efficient. Prompt engineering. Most people think prompt engineering is just like you are typing something into ChatGPT and hoping for a good answer. But there is actually a skill behind it. And it's all about how you communicate with a model so it understands exactly what you want and how to get a tailored answer exactly how you expect. So that means you're gonna give a detailed and clear instructions and context. You're gonna tell the model who it is and what its role, and show examples of the results that you want. Each time you get an answer from the AI, you're gonna review it and improve your prompts step by step. OpenAI API. So the API gonna let you interact with the same model, but with one big difference: inside your own app, inside your website, your product. So with that, you are building like a chatbot assistant inside your tools. And it is very simple to do. It's just few lines of Python. You send a prompt, you get a response, and you're gonna display it wherever you want. So as you are building your AI systems, you're gonna notice that you cannot rely completely on OpenAI, because actually they are closed source. That means you have no control over the model, you cannot see how exactly it works. You're gonna pay a lot for using tokens every time, and if you are not using Azure, your company data gonna leave your environment, and this is a huge problem for many businesses. So this is where the Hugging Face comes into the picture. It is the biggest community library for AI AI models, there are already more than 2 million models over there. And the best thing, most of them are for free. That means you can go and find a model for almost any problem that you might encounter. And my friend, this is exactly why I keep repeating the same thing. As a data science in industry, we don't have anymore to train anything from the scratch. All what you have to do is just to find the right model for your business case and just fine-tune it. And the big advantage with the Hugging Face is that you can download the models locally at your machine and you can deploy it anywhere you want. With that, you stay in control. You can use sensitive data for the model because nothing is leaving your environment, and as well, you reduce the costs. So now let's say that you can talk to AI models, you can write really good prompts, you can build really cool demos, but this is not enough to build an AI system because you need to connect everything together, and this is where LangChain comes in. So you can use LangChain in order to orchestrate the whole process, to connect all the models that you need, the tools, the memory, and as well to build your business logic. So the AI can take multiple steps in order to complete a full task. And this is exactly what AI system does. It's not just like one prompt and one answer. We're gonna learn about RAG, Retrieval Augmented Generation. The issue is that all the AI models are actually pre-trained using public data, but of course the company's data are protected and not available publicly, which means AI models has no idea about your company's data. So we have somehow to connect the company's data to the AI model, and here comes the concept of RAG. So here how it works. First, you take all the company's data, PDFs and files, and you want to store them into something called a vector database. So all what you have to do is to turn a text into something fancy called embedding. It is just representing your text with numbers, and then load and store all those embeddings inside the vector database. So once a user asks a question, it's gonna turn into embedding, and the system gonna start comparing and searching for the closest match using semantic search. So once it finds the right information, the LLM model gonna turn it into a response. So it's all about adding a memory to the LLM model to use your real data instead of relying on what they were trained on. We all used AI chatbots like the ChatGPT. You write a prompt and it gives you back a text. But of course, this is not enough. Companies want more than a nice answer on the screen. They want an AI that actually gets the works done. And this is exactly why we have AI agents. An agent does first the thinking and then it's gonna take a real action. Like for example, maybe talking to a database, updating records, calling an API, and maybe triggering a workflow. And as well, it is great in order to automate a lot of boring tasks that we do normally at the work, like reading the incoming emails and responding to it, creating a summary of a meeting, and as well creating those boring Jira and ServiceNow tickets. So it is way more than just a chat with AI, it is an AI that is actually doing a work. The MCP, Model Context Protocol. Now, AI agents can only take real actions like checking emails, querying a database, or calling an API only if they are connected to the external sources. And here, my friend, there are like two big problems. First, if you connect your AI agents directly to the productive database, this is really risky. And the second issue, we have a lot of external systems and you're gonna end up writing and building connectors for each tool, and this takes a lot of time and efforts in order to create new connectors each time you are connecting a new system to the AI agents. And this is exactly why we have MCP. It fixes those issues. We're gonna add a safe and standard layer between your AI agents and your sources. And this has, my friend, a lot of benefits. First of all, you can plug and play any system to your AI agents without creating each time new connectors. Using this layer gonna give you a full control on how the AI gonna interact with your sources, where you can add a lot of policies in order to protect your external sources. So using MCP servers and protocols, it gonna makes everything like faster. You can connect a lot of things, and as well you're gonna feel safe connecting AI agents to your sources. If you like this type of content where I'm sketching stuff and I'm showing you all things behind the scenes, then support my work by subscribing, liking and commenting and sharing it with other people like you. And you can check my website for the other courses like the SQL and Tableau. You can follow my written content in my newsletter and LinkedIn. If you're still here, thank you so much for watching, and I will see you in the next video. Bye bye.